Okay, everyone, going to continue with 5.4. This is page 3. Going to get into the word problems now. The first thing you'll see is you'll see these terms a lot, angle of elevation and angle of depression. The key is they are always measured with respect to the horizontal. So it's between a line of sight and a horizontal line, okay? It's just that angle of depression goes or below the horizontal. Angle of elevation is above. Otherwise, they're pretty much the same thing. So I've got a couple of examples that describes them. Number 10, let's say a point on the ground. So where's ground? Point on the ground, 75 feet from the base of a flagpole. There's my flagpole. The angle of elevation to the top is 56 degrees, 40 minutes. So make a line of sight, and then there's the horizontal, and there's angle of elevation, 56, 40. Okay, and then that was 75. Okay, and the question is, find the height of the flagpole. Let's just call it X. So we can look at the 3 values that we have, and the key is to getting the picture. Sometimes the picture is given, which is nice. Otherwise, you have to draw it. But notice we have an angle, and then we have the side that's adjacent to the angle, and then we want to know the side that's opposite the angle. So the 2 key players are opposite and adjacent. And so think about SOHCAHTOA. That's always your key here to figuring out which trig function to use. Opposite and adjacent are together in the tangent. Notice both sine and cosine have hypotenuse, and we don't know the hypotenuse, nor do we care what the hypotenuse is. So we're going to use tangent. So the setup here is tangent of the angle is opposite over adjacent. Okay. And then I'm just going to solve for that. So X is going to be 75. Multiply both sides by 75, just algebraically. And I'm going to calculate that out. All right. And then it said round to the nearest foot. Okay, so go to the calculator and we're going to do 75 tangent and then 5640. So 56 plus 40 divided by 60 is the cool way to do that. And this is about 114. Okay, and we're good to go. Okay, so those are sometimes a little bit better because I don't have to solve the entire triangle. I just need to find one side. Okay, let's try another one. The next one is even better because there's a picture. From the top of a cliff that's 210 feet, you observe the lighthouse that's 430 feet offshore, right? Find the angle of depression. Okay, notice the angle of depression in the picture, it's measured with respect to the horizontal. Now, think about from geometry, opposite interior angles are equal. So if this angle is here, then this angle is the same. So really you can just find this angle right there. Okay, those angles are equal. Okay, so that angle, the side opposite that angle is 210, and the side adjacent to that angle is 430. So again, it looks like a tangent, right? So I'm going to do tangent again. Tangent of the unknown angle is 210 over 430. All right. And then to figure out the angle, we've got to do tan inverse. So there's my calculation for this one. Okay. Let's see what that is. So I'm doing second tan. Let's get that tan inverse. And then 210 divided by 430. And it said round to the nearest degree. So that's about 26 degrees. And we are good there. Okay. So approximately 26 is the angle of depression. All right. The last type of problem you'll see in this chapter is bearing. And bearing is used in navigation, and it refers to a direction of travel, usually with boats, airplanes, that kind of thing. And there's two methods. So the first method, if just a single angle is given, then it's understood that the bearing measures clockwise from due north. And then there's some pictures of that, right? So if the bearing is 32 degrees, that means the airplane is traveling 32 degrees clockwise from the north, right? There would be the plane's travel right there, okay? So here, 164 would be heading in that direction. Kind of like you're looking down on the plane or the boat, right, from above, okay? Where method 2 is a little different. It gives you a north-south line. So you'll see something like this, north 42 degrees east. That means from the north, go 42 degrees towards the east, right? Because over this direction is east, right? Or south 31 degrees east. From the south, go 31 degrees east. Or south 40 west. West is that direction, right? West is over here. Again, you're looking down from above like a compass. Okay, so that's the method 2. And we'll do a couple of examples with both of those methods. Let's just scribble there. Let's start fresh. Okay, so for this one, a plane is traveling on a bearing of 30 degrees. Okay, so think about a compass, right, where this is due north. Right? And if the plane is traveling 30 degrees, that's 30 degrees clockwise from the north. There's 30. This angle right here, 30. Okay? And then pretend that it just does a dead stop for these problems, turns and flies 2.8 hours at the same speed at a bearing of 120. So if the plane is right there, do a new set of axes. That's what I do. And then do a 120 degree bearing from there. So that's 120 degrees from the north. So down 120 like that. So this angle right here is 120. Okay. And then so the plane went here and then there. And the question is, how far from the original starting point? So what is this distance right here? That's our x. Okay. Now, to notice here that this is going to be a right angle, right? You might be able to figure that out in a few different ways, but that is a 90-degree angle there because of this is 30, that's 60, right? And if this is 120, this is 30. Okay, and so then this is 90. Might take a little bit to kind of think about that, but and they set these up so you do end up with a right triangle, right? Because we're doing right triangle trigonometry. So that's always going to happen in your problems. Okay, so really what you have here then is Pythagorean theorem, because you can figure out how far they traveled, and then what's that distance. All right. So the first leg was 1.5 hours at 160 miles per hour. Right, so 1.5 hours times 160 miles per hour. The hours cancel, and it's 1.5 times 160, which is what, 240? Okay. And then the other one was same speed, but for 2.8 hours. So 2.8 times 160. That's 448. Okay. So just to highlight that, this distance right here is 240 miles, and this distance right here is 448 miles. What's this distance here? We can see that's the hypotenuse, so that's Pythagorean theorem. And that's all we're going to need. So we have x squared equals 240 squared plus 448 squared. So x is going to be the square root of all of that. And that's what I'm going to enter into my calculator for my final answer. All right, so I'll jump back to my calculator and do Pythagorean theorem. So square root the whole thing, and it's 240 squared plus 448 squared. And then enter. And I'm getting 508. Okay, so I'm going to put 508 and nearest mile. Good to go. Okay. Cool. All right, and this next one, let's start fresh here. I was kind of playing around with the pictures earlier. This one, we have one ship going 23 degrees northeast. That would be there, or there's that 23. Right, 2330, I'm just going to put 23 for now. And then south, 66 east. 66. All right, and it's the same type of question, but just with a different type of bearing. How far apart are they after 5 hours? So again, if you do a little work here, adding those up is 90. So this is 90. Okay, because that's their straight angle 180. All right. So again, we can do Pythagorean theorem as long as we can figure out the lengths of the sides. So let's see. This first leg, 25.2 miles per hour for 5 hours. Right. So I'm just going to do 25.2 times 5. That's 126. And then the other one is 14.4 times 5 hours. And that's 72. Okay. And then again, we are set up pretty nicely for Pythagorean theorem. This length is 126. This length is 72. No two sides need the third. Right triangle. It's Pythagorean theorem. Right. So I know I'm going to have x squared equals, so I can just do square root, right? Square root 126 squared plus 72 squared. And that should do it. So let's see. Square root 126 squared plus 72 squared. Okay, and this is nearest 10th of a mile. 145.1 would be my final answer. Okay. And we did it. All right. No more problems. Number 5. All right, we're good. Okay. That's the end. That's the more problems. You'll see similar ones in your homework. And that's the end of chapter 5. 1 chapter down already. How about that? Okay, 3 more to go. Send questions my way if you have any. Otherwise, I hope all is going well, and I'll talk to you soon.